Good morning, afternoon, and evening from wherever you are, and welcome to another episode of Unveil the Future podcast. This is episode 7, and we are fast approaching the finale of the first season. I'm Vân Nguyễn, your host, and today I have the absolute honor of welcoming back one of our laureates for 2023 VinFuture Special Prize for Women Innovators, the esteemed atmospheric chemist, Professor Susan Solomon. Globally recognized for her contribution in atmospheric science, Professor Solomon's pioneering work in discovering the Antarctic ozone hole has led to the development of the Montreal Protocol, which is a landmark international agreement to protect the Earth's ozone layer. This is one of the most important international accords to tackling environmental concerns, contributing to a global agreement to phase out ozone-depleting compounds. With a lifetime dedicated to atmospheric science, Professor Solomon is a true inspiration and a leading voice in addressing environmental concerns. Join us today as we explore the challenges facing our planet and uncover the inspiring solution that Professor Solomon believed would safeguard our future for generations to come. Hello, Professor. It is so good to be reunited with you, and thank you very much for accepting our invitation. It's been 8 months since you were honored with the VinFuture Special Prize for Women Innovators in 2023. I am curious on how this achievement has impacted your life and career.
Well, honestly, I think the most moving part of it has been the way a number of young women scientists, people sometimes that I don't even know, have noticed about the prize and have told me how much they think it's wonderful and what an inspiration it is to them. Is a wonderful thing. Um, that's been the most notable piece of it. I'm obviously very thrilled to have gotten the prize. I'm just so focused on my work. I just keep working on what I was working on. So it hasn't gone to my head or anything like that. I think it's fair to say, but it is inspiring how many young women are noticing and feeling like it's a great thing.
With this significant accolade, I have no doubt that this award has influenced and expanded new opportunities or collaborations for you. Since the VinFuture Prize, what exciting new project have you been working on?
We're doing a lot of interesting work on the chemistry of wildfire smoke. Wildfires are becoming a bigger and bigger problem in the world today, really, in many different parts of the world. And understanding the atmospheric chemistry of that smoke, what it's doing to pollution levels, how it forms, all those things are absolutely fascinating to me. It seems to be a particularly dangerous kind of smoke. So yeah, it's a very important question, I feel, so I'm really driven to work hard on it with my students and my postdocs.
Professor, you were honored with the discovery of the ozone depletion mechanism in Antarctica, contributing to the establishment of the Montreal Protocol. And from what I gather, you were the youngest and the only woman leading your Antarctic expedition at just 30. So what was it like being the sole female head scientist on such a groundbreaking project?
Well, many people have asked me that, and honestly, I can only say that the team that I worked with was a bunch of phenomenal guys. They were so helpful and so supportive. I never experienced anything negative from them. Yes, I was only 30, but I had done some work on trying to explain why the Antarctic ozone hole was there. Different ideas were floating around about how it might have been formed, and I had done, I think, what's fair to say, my most important paper on a mechanism, and then ideas about what we would need to measure in order to see if that was correct or not. So many people respected that work already because it was so important to have it. And what ended up happening was they knew that as we made decisions about what to observe and how to observe, that I would be a good leader for the team because we had to really think about, how we could make measurements that would help with this problem. And that's, I think, probably part of what was going on, but also they were just really good guys. I mean, sometimes you get lucky. And I really feel like that's what happened to me. These were amazing people to work with. The only difficult people turned out to be the people in the support teams. So, you have a station in the Antarctic, you have teams that take you down there on airplanes and such. And those have a few more old school guys maybe, and they don't know anything about science. They have, but ultimately they turned out to be okay too. It's just that it took a little more work with them.
Your instrumental research led to one of the most successful international agreements to phase out ozone-depleting substances, which is the Montreal Protocol. Can you share with us the moment you first saw your research translated into the real-world policy? And how do you see seeing those CFCs and other ozone-depleting chemicals slowly banned on a worldwide scale?
It's just an overwhelming sense of, um, how can I describe it really? A sense of gratitude that um, the world was wise enough to make these decisions, to make changes. Um, and I felt really unbelievably lucky. I mean, some scientists had to be involved in this. I firmly believe that, policy doesn't happen magically on its own. It takes many things, but one of the things it takes is a strong underpinning of science that is trusted science and clear science for people to be able to understand why we needed to give up these molecules, and so I felt really lucky, and I still do, that I happened to be the one to work on that. Science alone is never enough to make environmental policy, but it's always necessary. Somebody had to do it, and very luckily it was me.
You have seen the impact of the Montreal Protocol ever since it was established in 1987, as well as the ozone layers, how it's recovered in the recent years. This protocol aimed to prevent around 100 to 200 billion tons of CO2 emission by 2050. From your perspective, how are we doing with this objective?
Okay, well, I I want to make clear that the main thing causing climate change is carbon dioxide. That is by far the major forcing agent for global warming. That is governed by a different agreement, which is called the Paris Agreement. And the issues surrounding reducing carbon dioxide emission are have some similarities, but they're also quite different to the issues around reducing the chlorofluorocarbons that cause the ozone hole. So, but the chlorofluorocarbons themselves are greenhouse gases. So they also contribute significantly to global warming. And the really cool thing is we got a big bonus by phasing out the chlorofluorocarbons, where our goal was really to save the ozone layer. We also reduced the equivalent amount of CO2 emission, or the total greenhouse gas forcing of climate change. And if we had not done that, by 2050, we would have had an extra 1 degree of global warming, which would have meant we would be well over the 2-degree mark probably by that time. So perhaps it was a lucky thing in a way. It wasn't really done with this as a deliberate outcome, but certainly the Montreal Protocol has made a major contribution to avoiding the future global warming. However, when you get to CO2 emission, now you have, but when you want to regulate chlorofluorocarbons, what you have to do is regulate the chemical industry. Companies that make chemicals make a broad range of chemicals. They've been regulated before, and they have many different chemicals that they make. So it is not as difficult to make them change as it is to make industries that produce fossil fuels to change. The real problem is twofold. One, that the fossil fuel industry is incredibly embedded in what they do. There's $40 trillion of investment in fossil fuel infrastructure worldwide that has to change. I mean, we can continue to use the things that are already here, like our cars and our gas stations and stuff like that. But we're going to have to stop building new ones very, very soon, or we're going to have a major problem on our hands. We already have a major problem on our hands, but an even worse major problem on our hands. So that is a much bigger lift, a much more difficult thing than changing the chlorofluorocarbon industry, where their investment level worldwide was only a few $1 billion. It's a much smaller industry, much smaller investment. You know, anytime you have large amounts of money involved, you know, funny things start happening. It's not just about science. It's not just about what people want. But the good news is that there are alternatives now. I think when you look at fossil fuels, it's become very clear, for example, that we don't have to use them in our motorcycles. You know, we can have electric motorcycles. We can have electric vehicles. We can have solar and wind power, which in the long run is cheaper than fossil fuel energy anyhow in 75% of the world. So we find that I think the technologies for alternative options have gotten cheaper so fast that we're now at the point where we can also solve the climate problem. And that will happen via the Paris Agreement mainly, as we work on decreasing CO2. So I'm sorry to give you such a long-winded answer, but it's actually a very complicated question.
Many global endeavors have been made to address climate change. A recent example is the potential collaboration between the US and China on space-based solar research program, pushing for net zero carbon emission in 2050. So what is your thought on this collaboration and on countries' responsibility in the war against climate change?
Well, countries around the world have a responsibility first and foremost to their people, which is to do everything that they can to avoid future climate change, which will be damaging to society. There's no doubt. You know, there's an estimate that it's too bad that most of the estimates are in developed countries, but I just saw one about the estimated number of people that have died in Europe this year from heat. And it's surprisingly high. It's like 40,000 people. Amazing. And certainly in India and other parts of the world that have had severe heat waves and flooding, many, many people have died. So the first responsibility is to the people to be part of the solution. The next responsibility, I think, for the developed countries is embedded in the Paris Agreement, and that is to recognize that it's the emissions from developed countries that are the primary reason why we have climate change. You know, Vietnam has not emitted very much carbon dioxide. Even on a per capita basis, it's emitted even less. In the United States, we've emitted a lot. And it's not just us, it's also Europe and China, to some extent Russia. But those are the main ones. And those countries that have caused the problem, I think, have a responsibility to play a larger role in fixing the problem. And that includes aid to developing countries so that developing countries can avoid having to invest in expensive things like, you know, gas stations and cars and other stuff that they then are going to have to get rid of or phase out more quickly. So, you know, getting the energy supply to be renewable across the world is a major responsibility, in my opinion, of the developing countries. Clearly, you make the problem, you fix the problem.
And Professor, I have recently updated that you just released your book. And to open this, you said, "I have hope for this planet." That was the opening line for your latest book, Solvable: How We Heal the Earth and How We Can Do It Again. And this book, it had taken the world by storm by its positive narrative regarding the current environmental issues. So, what inspired you to write such a hopeful message? And what successes have we gathered in order to reach the conclusion that the environmental challenges we are facing are solvable?
Yeah, it's a great question. I've been studying this issue of environmental progress and how we achieve it really since I started my career. So we're talking about 1980. That's a long time. And I, over those years, just began to see patterns of how we succeed in solving environmental problems and how many problems we've actually solved in the past. So I started teaching that as I became a professor. And I found that it was a wonderful experience for the students to actually see that it's not always gloom and doom. Sometimes we actually do good things for the planet, and we have done a lot of good things. So I decided to write the book to spread that message. The kinds of things that you can cite, and there are plenty of them, include the one we've just been talking about, fixing the ozone hole. That was an unmitigated environmental success. It's the signature environmental success story where we've really phased out the chemicals that were causing the ozone hole to form, and the ozone hole is now beginning to heal. That's tremendous. But another one that many people don't know about is we got rid of lead in gasoline. That was poisoning people worldwide, children especially worldwide, and that was phased out. We got rid of lead in paint, another big cause of lead poisoning. We improved the situation on smog in many countries. I think there's work to be done in some countries, including Vietnam, China, India. But in the developed countries, the kinds of technologies that became available in the 1970s and 80s were great at solving the smog problem for places like Los Angeles. Los Angeles used to be worse than New Delhi. I mean, it was horrible, and now it's actually pretty good. So these kinds of things need to be learned about so people can think about how did that happen? And in every case, I think you find citizen engagement to be really critical. People have to really care about the problem. They'll care about the problem when it's personal to them, when they fear it for their own sake, not somebody else or some other country. When it becomes perceptible, they can, smell the smog in their own nose, or they can actually see the color images of the ozone hole. It doesn't have to be something you see with your own eyes, but it has to be easy to understand. And finally, when we have practical solutions, and the way we get to practical solutions is by steering the technologies to move in a certain direction so that we can get rid of the thing that's causing the problem. In the case of leaded gas, for example, the big innovation there was to bring in other ways to actually make the car run better. You didn't have to have lead in the gas to make the car run well. At one point, people thought they did or believed they did, but then it became clear that that wasn't true.
How do you see advancement in atmospheric chemistry facilitating solution for some of the environmental challenges that you have mentioned in the book?
Like everything else, it depends on the challenge, which one you're talking about. I think when it comes to, say, air pollution, which we've just been talking about, the great thing is that we can have a win-win here, because if we get rid of the fossil fuels, because we're concerned about climate change, and we go to an all-electric transportation system, that will enormously clean up the air worldwide. So there's a lot of emphasis now on figuring out how exactly to achieve that, and how to achieve it as quickly and efficiently and cost effectively as possible. It's going to be probably very place dependent. In different countries, you can use different tools, but in the end, an all electric system is what you're going to have when you have dense cities. One of the problems in places like Beijing and New Delhi and probably Hanoi too, is that you have a large population in a small area. Los Angeles has a large-ish population, but it has a big area. So the problems in different countries are not the same. And the nature of the weather in different countries is also not the same, which affects this. So that's just one example among many of how technologies will help us to figure this out as we attack it place by place.
As you have said in your book, climate change is a complex and often daunting issue, creating so-called eco-anxiety. So what advice would you offer to individuals who feel overwhelmed by the scale of the problem, but still want to make a difference? What specific actions or mindsets do you hope to cultivate in the young readers?
Well, I think the first thing to do is to get involved with the problem at whatever level you can do it yourself. So, one of the things that you can do is just talk to people about it. Talk to people in your school, in your church, in your community centers, whatever group activities you may have. Raise the conversation because people need to, I think, share the idea that they want to have a change if they're going to force a political change. Another thing that you can do, of course, is to make a personal choice. So, for example, you can switch out your vehicle to use an electric one, or you can choose to eat less meat, at least in developed countries. That's something a lot of people do. I know that in probably in Vietnam, there is already a very healthy diet. It's also good for you, which has a great benefit. So I think making personal choices, getting engaged in the discussion around it. If you have, if you're rich enough to have financial investments, you can make choices about what things you invest in. If you have a retirement account, for example, you can make different choices about the clothing that you buy. You can basically in any country, you can get engaged with the Paris Agreement process, and you can find out what your country is doing under the Paris Agreement and express your views. All those things make a big difference.
Having witnessed significant environmental progress over your career, are you feeling hopeful about the passionate activism of young people today in addressing climate change and other environmental issues?
Oh, I'm definitely feeling hopeful. I think that we have to just not panic, but we also have to realize that the situation is urgent. So we need to work on it as hard as we can. And in countries like mine, the more that people like me do things to tell their political leaders that they're concerned about it and they want to see change, the more changes will happen. And they are happening. I mean, in this country, we passed something called the Inflation Reduction Act during the last couple of years. It has been a real game changer. It's providing incentives for clean energy to grow quite rapidly, and for people to make better choices on a lot of things. It's electric vehicles, charging systems, changing the way that we regulate certain electric provisioning, stuff like that makes a big effect.
And finally, Professor Solomon, given your extensive experience in atmospheric science and your global perspective, what emerging research areas or collaboration opportunities do you see as promising for developing nations such as Vietnam to mitigate the impacts of climate change?
Well, again, I think the number one thing to focus on is air pollution, quite honestly, because the two problems are tightly linked, air pollution and climate change. Solving one solves the other. It will improve the health of the local people as well as contributing to the global reduction of carbon dioxide. So understanding air pollution in different regions and making scientific progress on how to actually control it in a way that would do both things, improve CO2 reduction and also reduce the particles that are the main cause of asthma and death in human beings is huge. So for many countries, I think studying and improving upon air pollution is really key.
Professor Solomon, your insights and optimism are a true beacon of hope for this planet. And thank you for sharing your wisdom with us today and inspiring us all to be a part of the solution. And to our dear listener, thank you for joining with us. We hope that the content shared in these episodes had ignited a spark of curiosity and commitment to protect our planet. Don't forget that the VinFuture Prize is now opening for nomination for the 2025 VinFuture Prize. Thank you, and I will see you in the next episode.